Hello everyone. In this video we shall see the introduction to the object-oriented programming. So what is an object-oriented programming? How is it different from function-oriented programming? Why object-oriented programming is better than function-oriented programming? All these discussions we shall do in this video. First of all, let us know what is meant by an object-oriented programming. It's very clear that object oriented programming is a programming paradigm that organizes and structures software design around the concept of objects. So, here, if you take any object oriented programming language, the two terms which comes to our mind which are very important are objects and classes. So basically, object oriented programming is a paradigm which is in and around the objects. So, what are objects? Objects are the instances of the classes. Let me give an introduction or let me give an example to prove why object oriented programming is required. In a software development industry, I'll take an example of one employee. An employee is identified by means of several identifications. Example, employee ID, the name of the employee, designation of the employee, number of years of experiences of that employee, what is his date of birth, what is his gender, what is his contact details, what is his email address, what not. I can talk like this around 20 to 30 different features of an employee. So when I talk about an employee, I have to depend upon a language which supports object oriented programming because I should consider an employee as an object, not as a variable. If I take an example of C, programming in C, most popular programming language, which is a function oriented language, wherein it provides me an option to identify any entity by means of a single value. So it will allow me to identify an entity either by means of a name or by means of an employer ID or by means of the different parameters or one of the parameters. I cannot include all the parameters by using function oriented languages. In order to cope up with these requirements using function oriented language, structures are implemented. Basically, the concept of object oriented programming is extended from the concept of structures. So let's see what is meant by an object. As I mentioned, objects are the instances of classes. In other words, if I say, what do you mean by an object? Object is basically a variable, but the variable contains multiple information. What are those informations? These informations are defined in classes. That's why we call classes as the blueprint. For example, if I want to define employee as an object, I need to define a class. I need to give the blueprint of an employee. How? Using classes. Wherein I need to define his name, employer ID, and date of birth, his designation, his number of years of experience, etc., etc., etc. So, what and all are required to me, I'll be defining them inside the classes, which I will call it a blueprint. So, any object which is defined will be instance of the class, which means basically if you start thinking object in the language of C, it's nothing but a variable. If I define a variable, see in C, I'm having a lot of restrictions. What are the restrictions? My variable could be only integer, or it could be float, or it could be character, it could be string, it could be boolean. Very limited. I cannot have my own definition of defining the variables. But here, in case of object oriented programming, I can definitely get the blueprint of my requirement by means of the class, and I can define a variable which I call it an object, which is the instance of that particular class. That is a basic difference what we observe between the function oriented language like C and object oriented language called C++. C++ is not the only object-oriented programming language. We have many, but the basic object-oriented programming language is C++. So here, two terminologies we have to be very careful. First one is an object, and second one is a class. Class gives a blueprint for an object. Object is instance of a class, means similarly if I want to relate this to a C language, a is a variable of type int. Normally we write int a. What is the meaning? A is a variable of type int. Similarly, object is a variable of type class. So object is an instance of a class. So this is a first concept which we have to understand. Now why is this important? So this concept of object oriented programming is very much helpful for developing a program using modularity, reusability, and encapsulation, which are all very important requirement for software development. Any programming language which supports all these paradigm will be highly entertained in software development industry. Now let's see what are the difference we observe between function oriented programming language and object oriented programming language. So now basically what are the differences between C and C++? C being a function oriented language, C++ being an object oriented programming language. So let's see. Function oriented programming language focuses on the functions or the procedures, which are the central components of a program. Functions or the procedures are the central components of the program. We write functions. Let me explain you in main. Main is a function. I may use or we may use different such functions like factorial or recursive functions or user defined functions. Like this is entirely a programming language which concentrates on functions as well as procedures. But object oriented programming language also supports function oriented language. So C++ also supports function oriented language. Then even C also supports function oriented language. language. So both are satisfying the condition of function or procedure oriented language. Then data and functions. This is a very important concept in any function oriented language. Example C. Data is separate, function is separate. We are supplying data to function. If I want to give example, we have three different types of functions in function oriented programming language, namely function without any argument pass, without any return, function with argument pass but without any return, function with argument pass and with the return. Here data is separate. You're defining a data separately. You're giving a value to that particular variable separately. You are using those data in a function. So data is used inside a function. So data is separate and functions are separate in function oriented language. Now, when it comes to structure of a function oriented programming language, we have programs which are divided into smaller functions. It could be broken down into any number of such smaller functions, which are then called to perform specific task. It's possible to write a single C program for a particular application, or it's even possible to write 10 or 20 small functions, and later on you can integrate them to get your work done. So any function oriented language supports the integration of smaller functions. This is what is called the concept of modularity. And each smaller function is associated with a small module, which will be used by the developers at the time of software development. Now, coming to another concept of reusability. Functions can be reused. If you write a single function, for example, you write an independent function for finding a factorial of a number using a recursion. This particular function can be used by any C program. It is not restricted to one C program. It's an independent small function which can be reused by any number of programming languages. For example, we are all using scanf functions, printf functions. Basically, these are all reusable functions in C. So, but maintaining their global state is a challenging one in case of the function-oriented language. Now, coming to another very important concept, encapsulation, which is very essential in the present programming environment. So here, in case of any function-oriented programming language, there is no question of data encapsulation. Data can be exposed, which leads to security. So any function-oriented programming language, data is not secured because data is not encapsulated. Data is exposed. When the data is exposed, it leads to security issues. So we have number of such function-oriented programming languages, say C, Pascal, Fortran. Probably Pascal and Fortran are outdated. They are not existing today. But definitely C is a very basic programming language which everybody needs to learn. And it's a classic example for function-oriented programming language. An example is very much given over here. See, it consists of functions. So they see, look at the screen. There are two functions which are used. There is a main function and another is a user-defined function called add, wherein data is simply getting transferred. 5 and 3 are transferred to a function called add, and the sum is written back to the main program. So printf is going to print it. So there are two functions we can see in a very simple program. It's a very simple C program which has got functions in it. So this is an example for function oriented programming language. Now let's go to the concept of object oriented programming. What is meant by object oriented programming? Here, the focus is given to the objects, which are the central components of the program. In the previous case, the focus is given to the function. Here, the focus is given to the objects. So, objects are the central components of the program. And another beauty of this particular programming language is here data and functions go together. Data cannot be separated from functions. Data is hidden inside the function. If you want to give any value to the data, if you want to access any data, you require the functions. So data and functions, these functions are otherwise called methods, are the one which are used to encapsulate the object. So, data and methods that operate on the data are encapsulated within objects. That means any data present within the object cannot be independently accessed. You require the methods, which are nothing but functions. You require methods or functions, and these methods or the functions must be given permission. If a programmer does not give any kind of permissions, then the particular function cannot be accessed outside. So, very much security can be provided. High level of security can be provided to the data. So, this is one feature which is not available in the function oriented programming concept. Now, coming to the structure of the program. The program is organized into classes and objects, and these classes and objects will prompt the concept of modularity and reuse. So by means of the classes and objects, there is a possibility of reuse, and it is a classic example for modularity. And coming to reusability. Reusability is also one of the strong features of the object-oriented programming, wherein you define classes and you define objects, which are the instance of the classes. These classes and these objects can be reused, it can be inherited. The concept of inheritance is also a classic example of reusability. The concept of inheritance means getting some properties of the object and generating a new object with the help of the parent object. That's what is called inheritance. So the detailed concept of inheritance we shall see in another video. So but the the concept is very clear here. The inheritance supports reusability. The classes and objects which are developed can be used for reusability. So object oriented programming strongly supports reusability. Then encapsulation. As I already told, object oriented programming strongly supports encapsulation because here data and methods they operate together within the object. So encapsulation is strongly supported. Here data can be a private data, it can be a protected data, and only the associated functions, only the permitted methods or functions can touch the data. Otherwise, data is not able to be shared. Nobody can touch the data otherwise. So, these are all the beautiful features of the object oriented programming which strongly support the programming in the real world applications. So, we know Java is a beautiful programming language which is currently used in the real world. Python is another beautiful program. Normally AI, ML, then data science people, statisticians, all of them are using Python. See, Python is a classic example of object-oriented programming. C++ is a basic concept. It's a basic object-oriented programming. Ruby on Rails, Ruby is also another example for object-oriented programming. See, this screen clearly tells about the structure of an object-oriented programming using C++. See here, a class is defined first. Just look at here. Class is defined. What is a class? Class is a blueprint wherein we are defining the variables. See, there are three attributes. One is brand, another is a model, another is an year. Where brand is a string, model is a string, year is an integer attribute which can be accessed only by a function called display info. So display info is an associated function defined within a class. Please make a note. Class contains set of attributes and a function, set of functions. Here only one function is given. It can be 1, 2, 3, 4, any number of functions it can have, and only these functions can touch the attributes. So we are giving the values, we are displaying the values to the respective attributes using a function. So all these are the part of the class. All these are the part of the class. So here a class called car is defined with the three attributes which are publicly available, and a function is defined inside the class wherein it is displaying the value of these attributes. Now a main program or a main function is written wherein a variable, or it's actually an object called my car is defined. An object my car of type car. What is car? Car is a class. An object my car is of type car. So that means car, my car is an object of type car. Car is a class. So my car contains three attributes. What are the three attributes? Brand, model, and year. For example, if you take you back, see here, I have only see int, only one value. Int result is equal to add of int A, int B. See, I don't have, see how many attributes A is having? Only one attribute, which is of type integer. B is another attribute, which is of type integer, only one. User does not have any freedom to define his attribute. So function oriented program does not allow you to define attributes of your type. So it's possible only with the object oriented programming. So in case of object oriented programming, I can prepare a blueprint by developing a class. So I develop a class called car. Here I can have any number of attributes. It's of my wish. Type is also of my wish. So number of also my wish. Number of functions associated with that particular class is also of my wish. So here I have defined my car. See, if I try to compare, basically it's not possible to compare. My car of car is equivalent to int a. What is int a? A is a variable of type integer. Here, my car is an object of type car. This is an object. Earlier, a is an integer. So, my car is an object of type car. See, how many? See, this object, my car, has three attributes. What are the three attributes? Brand is one attribute, model is another attribute, year is another attribute. Brand, model, year, which are defined inside the car. So now I'm giving the value. What is a my car dot brand? So whenever I define an object, every object will have all the attributes. For example, if I define my car, so three objects are there. What are they? My car dot brand is one attribute, which is of type Toyota. My car dot model is another attribute, which is Corolla. My car dot year is another attribute, 2020. Suppose if I define one more, let us say car space my car comma your car. So if I do so, I'll be defining two objects. One object is my car and another object is your car. So when it comes to my car, there are three attributes: my car dot brand, my car dot model, my car dot year, as it is defined inside the class. Similarly, your car is also another object which is defined, which will have your car dot model brand, your car dot model, and your car dot year. So these are the values which are given to the attributes. So see, one very important logic I can mention here. I have given a value to brand, model, and year, which are attributes of this particular class in the program itself. It is allowing because I have declared them as public. If I mention here as a private, then this cannot run because any private attributes can be touched only by using a function. Function should be public. This function only can touch these attributes if I define it as a private. But I have defined it as a public. That's why it's allowing me to give the value at the main program itself. So very simple structure of an object oriented programming. It contains class. The structure is it contains a class containing attributes and member functions followed by the main program. So very simple. The concept of object oriented programming is very simple, having class as well as the main program. Now let's look into the comparison in terms of table. The main unit of a function oriented programming is functions. Any function oriented program, we are talking by considering functions as a center of attraction. But when it comes to object oriented program, we talk about objects, not functions. Coming to data and behavior, every function oriented program, data is separate, function is separate. There is no concept of encapsulation. But when it comes to object oriented programming, Data is encapsulated within objects. So this is another very important difference. Coming to reusability. In case of function oriented programming, any functions can be reused. Data you can separately give it. Functions can be reused. But when it comes to object oriented programming, you can reuse the classes as well as you can reuse the objects also. Now coming to encapsulation. Function oriented program doesn't enforce encapsulation, but object oriented programming strongly recommends encapsulation. So it is enforced. Data encapsulation is enforced in object oriented programming. It's not easy to get the data using object oriented programming straight away, but it is easy to get the data straight away using function oriented programming. Now, state management. Normally, function oriented programming relies on global variables. So it depends upon some of the global variables. But when it comes to object oriented programming, it manages through object attributes. Then coming to inheritance, there is no support for inheritance using function oriented programming. Inheritance is strongly supported by object oriented programming, wherein the concept of reusability, as I already mentioned, there are 2 to 3 classes. There will be one more class which can be defined by taking some of the properties of the other classes, which are called parent classes. The concept of that is what is called inheritance. So in a different video, you'll come to know the entire concept of inheritance. Now, coming to security. Any function oriented language, data is less secured. But when it comes to object oriented programming, data is highly secured. So controlled access is only the method of access to the data. But in function oriented language, data can be accessed anyway. Examples we have already discussed: C, Pascal, Fortran, these are all the function oriented program. But when it comes to object oriented program, Python, Java, C++, Ruby. So Python, Java, C++, Ruby, even all object oriented programming languages strongly support function oriented concepts. But function oriented languages, programming languages, do not support object oriented concepts. So these are the major differences what we observe from the function oriented language and object oriented language. Now let's look into the benefits of object oriented programming language. First one, code reusability. With the help of inheritance, classes can be reused so that redundancy is reduced and development time while improving maintainability is also improved. So object oriented programming concept strongly support code reusability. So code reusability is one of the important features which are required in the programming environment. So here, see, there are 2 classes. Vehicle is one class, car is another class. So I can define my car as of type car, wherein I can use the old one, start. That is what is called reusability because it's a base class. Honk is a new method. See, car, honk. Honk is a function defined inside a car. I am defining a object of type car. See, I am defining object of type car. I have never used vehicle, but vehicle is an existing one. So, but I can definitely use it. I can use a function. So this is how use the I can use the classes and functions. which supports reusability. Very simple example which is given, which supports the reusability. Now, modularity. One of the major or one of the very important requirements in the IT development or IT industry while developing a software is modularity. So the concept of modularity is breaking down the complex tasks of software development into smaller and smaller and smaller and smaller and smaller pieces and developing such smaller pieces. For example, if I want to develop a software for, let us say, learning management system. Learning management system is a huge software to be developed. It's a big software to be developed. If I want to start developing such a software, I have to break down. I have to break down that into smaller pieces. So the concept of breaking down the software into smaller pieces is what is called modularity, modularization. So the entire learning management system, I can split them into say 100 or 200 small pieces. So which can contain self-contained classes so that it's easy for me to develop or to debug or to modify also. So the benefit of modularity is it enhances the readability and simplifies the troubleshooting. Coming to third option, encapsulation, as I already mentioned, very important feature wherein you are combining the data, which are otherwise called attributes, and methods, which are otherwise called functions, into a single unit called a class. I already mentioned what is a class. Class contains a blueprint of the object. Basically, class is nothing but the encapsulated concept of attributes and functions. Both should go hands to hands, or both should go together. So your attributes and methods should go hands to hands, which are defined inside a single unit. That's the basic idea behind the encapsulation. So with the controlled access via access specifiers, you can access using private, protected, or public. So these are all the various features of the object-oriented programming which support the concept of encapsulation. So the basic idea is to protect the data from unintended interference and misuse. So we don't want, it's a current requirement also. Nobody should touch the data. Nobody should alter the data. So data must be secured. So encapsulation definitely protects the data from unintended interference and misuse of the same. So here is an example. See, I I will be see I will be sorry I will be see I will be going to this. See, I have defined balance as a variable of type double, which is of type private. So, other than these two functions, which are defined inside the class, nobody else can touch the variable called balance. That is encapsulation. The functions which are publicly available, see, the functions which are publicly available are only able to touch the variable or attribute which is private, defined inside the class. So whenever you define a private attribute, only the functions which are defined within the class can handle them. Nobody else can handle them. So balance plus amount. Amount can come from outside also. So amount, see, amount is defined inside here also. So we'll take that amount from outside, but balance can be touched only by the deposit and get balance, which are inside the class only they can touch the balance. So This is a concept which strongly supports the encapsulation. Now coming to another very important characteristics feature, that's abstraction. So what do we mean by abstraction? Normally, abstraction is needed when we want to know the features of the data, but we don't want to know the complexity in implementing those data. So these things come only at the time of coding. But before coding, we have a concept of design, wherein we don't want the complexity of implementation of the data, but we want to know what is the essential feature of the data. For example, if I take you back here, say I've defined a balance. What is the feature of a balance? Balance is connected to the bank account and it is going to show you what is the amount which is there in your account. But nowhere, nobody is telling how it is implemented. But everybody is telling balance is used to express the feature. But how complex it is at implementation stage, nobody is mentioning. So that is a concept of abstraction. What is the benefit of abstraction? The benefit of abstraction is improved or enhanced security. So, of course, we mentioned in enhanced security is one of the benefit of abstraction, but basically the concept of abstraction is very much essential while developing the software. So people who need to know the essential features only will be able to get the essential features, but they are not interested to know what is the complexity of the implementation. Complexity of the implementation is done by the developers. Complexity of the implementation is done at the time of coding, but people other than that need to know what is the essential feature of the data. As I mentioned, what is the essential feature of the balance? So you don't want the internal structure or internal complexity of the implementation. So that's the benefit of abstraction. As I already mentioned, see, look at here. I'm defining a shape with that publicly I mention a function called a draw. Okay. Then here I just mention publicly shape where I use a function called draw, but shape is actually a class wherein we just mention what does it do, but we never mention how does it do. Shape is the one which is related to a particular draw. So wherein we are drawing, what are we drawing, how are we drawing, we are not mentioning. But we mention a class called shape, means it is related to some figure. So that's a feature, but we don't give the internal complexity of the same. That's a concept. Then next is what is called polymorphism. Polymorphism is also one of the features of the object-oriented programming. So that an object can take multiple forms by using function overloading, operator overloading, and method overloading. And here I'm going to give you one feature which is different from function oriented programming, wherein this is what is called polymorphism. For example, I will take an operator called plus. See, C is equal to A plus B. What is the real meaning of C is equal to A plus B? C is a variable which stores the value of A plus value of B. That's all in the function oriented language. But when it comes to object oriented language, the plus takes multiple meaning. So plus takes multiple meaning. If C, A, B are integer variables or float variable, so the plus can have multiple meaning. Means C, A, B, if they are integers, it will do the integer addition. Whereas if you define C, A, and B as objects of complex numbers, And if you mention C is equal to A plus B, it goes to complex addition. So it will do multiple operations. So an operator, a single operator, if it is defined with the multiple operations, it is able to do that multiple operation. For example, I'll give another example. You define a function. So you can define a single function. For example, maximum of three numbers. If you mention max as a function with three arguments, you will get the maximum of three numbers. If you give four numbers, max, same name, function name also same, max with the four numbers, it will give the maximum of four numbers. Whereas if you mention max, same function name, with the five numbers, it will give the maximum of five numbers. But function name remain the same. This is what is called function overloading. But this feature, any function-oriented language never support. If you mention function as max as a function, there should be only one function, and arguments whatever are defined should be provided. You cannot use it for multiple operations. So polymorphism is one of the beautiful concepts which are defined in the object-oriented programming. As I already mentioned, say dog is of type animal. See, animal dog is of type animal. See, wherein it is overriding. So there are two features which are mentioned over here for the dog. Animal to A is equal to new dog. So here it uses both. It uses both. So it can use either animal or it can use either a dog. So anything is okay. So this is what is called polymorphism. Coming to scalability. So OOP supports the creation of large complex systems by promoting modularity and reuse. So because of these facilities, the OOP supports large creation of complex systems. So that's why today if you see Java, every industry uses Java. It could be mobile industry, it could be web-based applications, it could be server-sided applications. Whatever applications you see, Java is used because it's an object-oriented programming concept. So OOP supports creation of such large systems as well as such complex systems because it makes it easier to extend existing systems without breaking them. See, always any programming language you go, it should extend it. It should not replace it. So earlier version, whatever you have, it should be there, and your new version program should work on that earlier version also. This is what is expectation in the IT industry. So there is no question of replacement. You remove it and you install the new version. Nobody wants that. You should say that okay, it will work on your existing system and it is going to update your existing system. See that way, that is how you need to scale your program. So it provides such a good scalability, maintainability. OOPS provides a very good support for the maintenance, wherein it provides changes to the code base to specific classes. So it reduces the risk of unintended consequences. So it is able to simplify the updates. It will be fixing the bugs. Bugs can be fixed. So overall, maintenance activity is very easy using this object-oriented programming. Extension, extendability. So with the help of inheritance, polymorphism, new functionality can be added without altering the existing code. So using the existing code, using the existing program, it's always possible to extend the new concept by using. So one or the other way, it we are talking about reusability only. Basically, inheritance and polymorphism are the classic examples for the reusability. So, but these two features are the classic examples for the extensibility of the programming language. Security, very clear because of the data hiding, because of the encapsulation. Object oriented programming provides the highest level of security for the programming environment. Then, real world mapping. So, object oriented programming models real world entities through objects, classes, and their interactions. So basically, using object oriented programming, it's possible to address the real world problems so that you can definitely think of developing a real world applications using object oriented programming. So with this, a small brief introduction of the object oriented programming is completed. Thank you.